Ah. All right, just going to give it another minute for folks to show up. Looks like there's a few stragglers. All right, then. I'm going to get started. Thank you all for taking your Sunday morning to join us here at SCaLE and your contributions to making this conference a possibility for 17 years now. This is my first time speaking at SCaLE, and it's an honor because I've seen so many speakers ahead of me do the same thing. Today, it's my opportunity to teach you or share with you what we've learned in implementing GitOps for our customers and practicing or dogfooding it on our own. So I'm going to show you how you're going to enable your teams to operate more autonomously and efficiently by practicing operations by pull request. So here's what you're getting yourself into today. First, I'm going to share what is GitOps, and it's not rocket science. I bet many of you already practice some form of this today if you're continuously delivering your infrastructure as code. I'm going to convince you of why it's so awesome that you're going to want to go back tomorrow and talk to your manager to get permission to do it, or if you are the manager, tell your engineers to go look into this thing that I'm going to share today. I'm going to give you a hint on how to get started with this. Now, the presentation today is going to be pretty focused on Terraform. I'm going to give a little quick intro on what Terraform is in a few sentences. So you can take that and go and get started tomorrow. I'm going to follow this up with a live demo because I really believe in transferring practical knowledge to show you what it looks and feels like so you can see that it's truly awesome. You can go to the URL at the top and start submitting questions along the way. I'll get to those at the end. And we'll have a Q&A also at the very end so we can ask some questions. I think the whole presentation is not going to be more than 30, 40 minutes, so we'll have a lot of time over for questions. So my name is Eric Osterman, and I'm the founder of Cloud Posse. We're a DevOps professional services company based here in Los Angeles, California. We help companies typically with migrations. They approach us when they want to move from one platform to the other, like they're on Heroku today, and they want to go over to Amazon and use Kubernetes. Or perhaps they're already on Amazon, but for many years, and it's time for them to re-platform, improve their automation, and that's when they contact us. So the benefit by being a DevOps professional services company with one specialization is that we get to go really deep in one area and get to know it really well. We're not going to build your mobile site. We're not going to help you with any SEO. Occasionally, when mom calls, we'll help her out, but otherwise there's even pushback on that. So DevOps today is an amazing ecosystem. The tools available today are like none other. My company was founded to help bring the knowledge of how to integrate all these tools together to make it easier for you. And that's why we have over 130 Terraform modules that are all public and open source. We see over 10,000 unique visitors every single day hitting one of our GitHub repositories. And we have over 300 projects in total that we actively maintain. We see over 100,000 forks of all our work out there. So I feel like we're really contributing back and achieving our mission. So this approach to DevOps that we take, we call SuiteOps. And it's a collaborative process towards DevOps that translates really well across organizations. We live in an awesome time to be doing what we do. I liken it to a renaissance. When I got started working with the public cloud, it was back in 2006. Amazon had just announced a public beta or private beta for their cloud, EC2. So our startup, it was called Socialverse. We had just gotten off the ground, and we decided to give it a shot. We got into the beta, and all we had available to us at that time were M1 smalls and a little bit of courage, because there were no persistent volumes, no load balancers, no RDS instances, no Elastic Cache, none of that stuff. We were just excited we could automate like Nginx with a configuration and some scripts to point it to some instances. Anyways, the tools at our disposal today are phenomenal. We got functions as a service, serverless and lambdas, absolutely everything defined as code, software-defined networks, container management platforms that blow my mind. Like, this was not even remotely on my radar 13 years ago when I got started on all this. We use CI/CD to continuously integrate and deliver our software. And we've started taking that to the next level where we practice ChatOps, basically interacting with bots that control our infrastructure and our systems. And the last piece of this that I'm showing with you today is GitOps. And I'm going to explain why that addresses some of the problems. So for all the amazing things that we do today, I still see a status quo in how some things are done. That is that we have these complicated manual rollouts that are done via the terminal. As a result of that, we lack audit trails. We don't know what happened when that was done because it was done on some guy's workstation. It's not clear if that was deployed. So we lay these Easter eggs all over the place where something goes into the master branch and nobody actually applied it. So the next guy who gets to deploy the infrastructure gets to find hundreds of changes that need to be rolled out. And this leads to configuration drift, which is a really bad practice. We write a lot of documentation at Cloud Posse, and I confess that documentation is also out of date. And that's why the same thing happens in a lot of organizations. You have these documents that describe how to do your rollouts, but they only tell part of the picture. And if somebody else is to follow them, they can't do it. So now, as a business, you lack continuity, and it's a liability because if somebody goes on vacation or moves on or gets hit by a bus, nobody knows how to roll out the changes. Now, if you use Terraform, there's some more problems waiting for you. Many of you probably practice CI/CD today with your web applications. And the ideal web application is totally stateless. So you don't care how or what happens when a rollout fails. You have these health checks that detect a failure, and then you just go back to the previous release. I only wish we had the same privilege when we deal with infrastructure, because when we deal with infrastructure, it's a lot more like doing a database migration. And a tool like Terraform, it is a database of the desired state of your infrastructure. So when you do a plan or an apply in Terraform, what we're doing is we're taking the state of your infrastructure from one state to the next. And now I got to pause here because I realize I kind of forgot to introduce what Terraform is for those of you who maybe aren't familiar with it. So these days, Terraform is the leading tool for helping companies provision all of their infrastructure as code. Terraform is a simple DSL, domain-specific language, that makes it easy to describe, hey, I want a load balancer here, I want a couple instances behind that, I need an RDS or a relational database over here. So all of that is defined as code, and Terraform is the tool to make that happen. So this tool, Terraform, that is used by millions of companies, lacks some pretty fundamental things you'd kind of want from it. This is not the fault of Terraform, but Terraform won't automatically roll back in the face of errors, and that's because that's a difficult thing to solve. You need an operator to do that, and Terraform doesn't provide operators. That's where something like Kubernetes comes in. Anyways, the Terraform plan, it's just a best guess of what's going to happen, and if we just rely on that, and we merge everything to master, and we do our rollout, there's a good chance we're going to get a failure. And if you have a very busy organization where developers are branching off of master all the time, now that little change that you just did, that bug you introduced into master, proliferates across branches, and we have a problem. So my goal is to convince you that we can still do continuous delivery of Terraform or similar apps, but the strategy is what we're going to want to tweak a little bit. To make this a little bit more real, I'm just going to bring up, a very typical example, and I'm guilty of this. Look, this GitHub stuff is a pretty recent phenomenon. As a developer, I'm iterating and working on the code, I'm making it all work, and it always works perfectly on my laptop. Scout's honor. I mean, it's my honor on the line. I don't want to commit broken stuff. It always works on my laptop. Yet the day comes when a developer or another team now takes my change and deploys it to production, and we get some random error like this one. And what I'm going to show you today isn't a way to prevent those kind of errors necessarily from happening, but to make the process of iterating on these kinds of things easier, so that we aren't polluting the master branch and that we can move faster. And the math is pretty simple when we think about it, why this happens. So if we think about the number of tools that we leverage as part of our DevOps toolchain or our workflow, combined with the dependencies of those tools and the configurations, and they're all pinned at different versions, across all of our Amazon accounts, and in those accounts, we have different projects, and each one of those projects have their own software development life cycles. And then all of the different developers working on it who have historically been, let me see if I can get this working, who have historically been doing this on their workstations. and in our case, across all of our different customers, the number of combinations in ways things can go wrong is astronomical. So we want to get away from this. And the way we do that is we eliminate this. This is the final frontier that we want to get away from, is provisioning infrastructure from our laptops. And I'm going to show you one way we can go about this so that we make it really easy for teams to terraform stuff. And I truly believe that this can be made so easy in your organization that different teams, different developers, not just back-end developers, not just operations engineers can do this stuff, but anybody who has the competence to open up a pull request and see how other people have done it. And you can do this without giving up security, controls, and approvals. And I'm going to show you all that too. So we're going to solve this by practicing GitOps, and the concept is simple. So we have Git as our system of record. Since everything is software as code, or software-defined infrastructure as code, it can live in the same place of that all our other code lives in, which is something like GitHub. And then, to effect change, we open up a pull request. And this is the concept of creating a request that contains a log of all the changes that we want to introduce into the master branch. And we assign that then to somebody to review it, basically to take a look, a second set of eyes to make sure I didn't miss something. And then we integrate that with our CI/CD pipeline. Now, if you've used Jenkins in the past, it's the same concept, where we check that code out and we run a plan and we see what's going to happen. But we're going to change this a little bit, because in the traditional CI/CD workflow, what we're doing is we apply changes when we merge to master. But we don't know if this even works because we can't test it without actually deploying it. So we're going to introduce chat ops into this equation. And chat ops is basically interacting with the bot or the CI/CD system. So hey, bot, can you go run a plan? Tell me what's going to happen. And we're going to want that to post back to the pull request so we can see exactly what's going to happen. How many of you who are responsible for doing infrastructure right now are doing a code review process and actually check out that code that one of the developers did and test it locally? That's tremendous discipline. I don't have that much discipline, I confess. That is good. But even if we do that, the problem is that my workstation isn't going to be the same as his workstation, and we have problems. All right, so then we get an approval on that pull request. We're going to take the next step, and we're actually going to apply those changes. And if anything goes wrong, I'm going to show you that we have recourse in this situation. So let's see here. By practicing this, what you're going to achieve is basically a repeatable system where we can apply changes the same way every single time. And the benefit with this is then, if there are problems where that are not caught during the development process, we can fix those as part of this pipeline, because it's a single source, it's a single place where this should happen. Boy, this is kind of annoying. There we go. All right. So as a result of having it be very repeatable, we can achieve it, we can make it so it's very predictable. And predictable is that we can see what the expected changes are to happen. And it's auditable. So unlike the developer doing this on his workstation, where you have no insight into what actually transpired on the screen, this time we see everything in the pull request history, so we can go back and look at it. Because there's sometimes things we miss, and we want to go back and see, whoa, did this actually happen at another time? Or you lack the context or the conversation around that pull request, and that's what we're going to be able to do. And lastly, we make it accessible, since anyone who can open up a pull request can affect the change. So there's this small little tool called Atlantis, and I'm going to show and share how this solves the problem. So Atlantis was built for Terraform, but under the hood, it's just a simple service that runs commands from webhook requests that come in from your GitHub or your Bitbucket. We use it with Terraform. We've used it with CloudFormation, using the AWS CLI. Now, for those of you using Kubernetes, we've also used it for Helm and Helm File, which is a tool for deploying Helm charts or Helm releases. Many of you who are doing maybe more advanced Terraform stuff might be using TerraGrunt, and TerraGrunt is a great tool for large Terraform infrastructures. Or you might not be using GitHub, you'll be using GitLab or Bitbucket, on-prem or hosted. It still works with that. And if you use Docker, that's great because you can just deploy this as a simple microservice anywhere you can run your Docker containers. So this product came out of Hootsuite. They use it in development, staging, and production. They use it everywhere for many, many years now. The core maintainer ended up leaving Hootsuite and started this as an independent organization called Run Atlantis. And at HashiConf this year, or last year, it was just announced that it was kind of picked up now by HashiCorp itself. So Luke is now full-time working on this project at HashiCorp, which is a great sign that HashiCorp is investing in this open source project. And the flow is really simple. A developer, he's going to open up his branch. He's going to make all of his changes there. He's going to make sure it works. And once he feels pretty good about it, he's going to open up that pull request. And the very act of opening up that pull request is going to kick off a pipeline here. And that pipeline is going to use the credentials of the Atlantis server running in your infrastructure. Since it's running in AWS, we can take advantage of instance profiles and roles so we don't hard code any credentials anywhere. And then when Atlantis runs your Terraform plan and gets all that output, it's going to take that and post it back to your pull request as a comment. And what I've just described is this concept of an interactive pull request that hasn't really existed before. It's like the combination of pull requests with chat ops. So if you are not maybe a developer, the concept of like the Git workflow might not be totally familiar. And the workflow is something like this. The developer opens up a feature branch in Git. He does all of his work in that branch without destabilizing the master branch. When he's ready for others to take a look at it, he opens up a pull request. That pull request will show the change log of everything there as a diff, and you can comment on it. So any line, you can add a comment like, hey, did you mean to specify this instance size? So they can request changes or they can reject that pull request. Either way, that's the workflow. And this is what it actually looks like. And this is with Atlantis. So here, the first thing is, in this example, we're going to be adding a user to an AWS account using strictly pull requests. And this is kind of a powerful thing because imagine you hire a new guy, and through the onboarding process, the first thing he does is open a pull request against your infrastructure to add himself to it. But it goes through all your standard code review process. If you're using a code owner's file, you can request that certain teams actually are required to approve this pull request before it's applied. Anyways, here in the pull request, we see what the expected change is. I want to point out this thing with the keybase there. This is the secret to automatically provisioning users with Terraform on AWS. What happens is Amazon generates a random password, and you give it a public key that came from Keybase. So the password never touches any other person's hands. The only person that could have ever decrypted that password is the guy who knows the private key corresponding to that. Anyways, the act of opening that up triggered a plan. So Atlantis wakes up, sees there's a change, and calculates what's going to change, and posts that back as a comment. So this is actually a real comment from this demo that I'm going to do today. Using the code review process, somebody approves that. And because it's approved, we can now apply it. So we add a comment to the GitHub pull request saying, hey, Atlantis, apply. And we see the outcome of that. Now, if there was an error here we can go back and fix that really easily without having destabilized the master branch. And I'm going to show you that workflow. In the end, when it's all said and done, that's when we merge. I think that was a pretty easy workflow. And what's pretty amazing about that is the developer can just log into GitHub, look at other pull requests, and see how things were done. So it's a great form of knowledge transfer of how to do operations. Now you might wonder the kinds of companies using this today. And these are some of the ones that have come out publicly via Twitter and said how they're using Atlantis. This one particular comment by Shopify, I think, really captures the essence of what makes Atlantis so cool, is that it empowers any developer to make that change, but we still have all the power to approve or reject that, and we don't need to mess around with complicated IAM policies and permissions. In fact, we can almost eliminate everyone who has access to production and staging because we enforce a pull request workflow. Kelsey Hightower, who is a phenomenal influencer in our community, mostly in Kubernetes, but he was at HashiConf, and he tweeted out after the first presentation of this that this is super dope. And the Kelsey Hightower scale, that's, I think that's second from the top. So that's pretty hard to achieve that. So to get started is pretty easy. What you're going to want to do is use whatever process you have today to deploy a standalone, single process service that runs somewhere in Amazon. You're going to give it an IAM role. And then you're going to write an Atlantis.yaml manifest, which is the pipeline that describes how everything should work. So if you're familiar with Circle or Travis or Jenkins, all of those have pipelines as code. That's what this is, but for Atlantis. And it looks something like this is the deployment thing. So we have an open source Terraform module that helps us deploy it with our customers. Can't promise that it's going to work for your use case or how you have things set up, but at least it's a great starting off point to see how we deploy Atlantis. We use ECS Fargate because it's really hard to access that container once you deploy it, which is a good thing. And it has all the bells and whistles of integrating tightly with the Amazon platform for security. The Atlantis manifest looks like this. We define here a friendly name for the VPC. And the VPC refers to, oops. Wonder if, yeah, I'm thinking to do that. Thank you. Or maybe like this. Here we go. Improvise. All right. So we define this Atlantis.yaml, and in there we specify a directory, and that directory corresponds to this pipeline, and you can associate a workflow with that pipeline. That workflow is fully customizable, and you have two steps that you can customize. And maybe this isn't so good. It fades in and out. Test, test. All right, let's do that. Thank you. Sorry about that. Nah, that's all right. I just think the newbie guys in a minute. All right, there we go. All righty. So so this manifest file describes how this pipeline should work. I'm now down to the section here on workflows. Each one of those directories can be associated with a workflow, and this is what allows us to handle complex rollouts, so we don't have to assume the process is always going to be the same. I like to be very explicit, and that's what we're doing here. So we're defining what are all of our steps, and the first thing is run. So we're going to do a Terraform init, which is how we attach the remote state in Terraform. And then we're going to do a Terraform plan, and we're going to write the output of that plan to a file, so that after approval, that's exactly what we're going to execute when we run and apply. So there's a promise, a contract here
of what's going to happen. So I'm going to now show you what this actually looks like and what this feels like operating it. I'm going to go over here to my laptop, get this set up. See here, I don't have my hands free here anymore. All right. So to drive the point home at how console-free this process is, I'm going to do the whole process without ever leaving my browser. I'm not saying that this is what you have to do to change your development workflow. I just want to emphasize the point that we eliminated the console. So root.cloudposse.co, this is one of our public reference architectures for how we manage our infrastructure. This corresponds to our root AWS account, the top-level AWS account. In here, we have our configurations for different Terraform projects or modules. And in here, we have our users. I'm going to go ahead and create a new file in here. Call this demo for SCaLE.tf. And, well, okay, I'm going to cheat here. Going to go back and show you how anybody who's good at copying and pasting can do infrastructure. So I'm going to copy this, go back here and create a new file, paste that in here, demo for SCaLE.tf. All right. Now, this user already exists, so I'm going to change this to a demo user. Call this demo. I'm going to use my Keybase username since that's we don't have a sample for that. Going to change this output to demo. And I'm going to introduce a problem here, something that might miss code review. It's going to be, daemon, a little bug. And let's see here, everything else look good? Yeah. So create that. We have our pull request here. All right. So the very act of me opening up this pull request is going to wake up Atlantis, as we see it kicked off right here. And in a second, we're going to see the outcome of this. And I expect something to go wrong. Cool. We got a plan error, folks. And it caught the syntax error in my output here. So this is the kind of thing that would often be missed in a code review if you're just skimming over what's there. And since we haven't merged anything, I can just go ahead and go back and fix that mistake that I had. All right, so I commit that change. That wakes up Atlantis again. Atlantis goes and runs another plan. Here's that change. This yellow dot indicates that it's running in the background. Give this another minute to complete. Okay, there we go. So now we see the output, and we can see that it's going to want to add that IAM user. It's going to want to add that user to a group, and it's going to create a login profile so they can access the web console. Now, to prove to you that I can't just go ahead and apply this, I'm going to say Atlantis apply. And it's promptly going to reprimand me and say it failed because it must be approved. So I'm going to, yep. Yeah. So I guess that was unclear with my example being very demo-like. So here I'm actually adding a user called demo. Yeah, so the user is called demo with my PGP public key. So in an ideal world, that wouldn't be my key. It would be that user's key. And that's the disconnect there. Yeah. All right. So I'm going to go over to my YesMan account. Well, I'm going to first request a code review. Go over here and search for test and our test user. All right. So the test user is kind of like the engineering manager or the gatekeeper to making changes here. And the gatekeeper is going to look at the most recent plan here and see that everything looks good. And assuming it does, he's going to go over here and then, oops. Go ahead and review that code. Approve it. And there we go. So now I am over here. I've gotten my approval. I can go ahead and run Atlantis. Apply. What's happening in the background is it's going to take that plan that was previously generated and it's going to go and execute exactly that plan. And here's the output of that. So we can see it added that user. And here's the demo decrypt command. So the demo user can go copy and paste that into their terminal window to decrypt and get their Amazon login password. And the whole process was driven by Git. Now, to drive home also why this is so awesome is the whole offboarding process. So now that user, we don't want them anymore in AWS, or they've left the company, or they're no longer involved in that project. Well, let's go ahead and squash this first, since we've made that change. We can go delete that branch then. So here's that demo that we had for this conference, adding the user. I can now remove that user simply by reverting that pull request. So we're using the same process that we use for software development, traditional software development, for infrastructure management. So I can create that pull request, and we go through the same process. And I'm not going to show you all that because it's just what you just saw. But that's that. Let's see here. So I'm going to go back to... All right, so it looks like my sacrifices this morning worked. Demo went flawlessly. So here are some of our best practices now for doing Atlantis in practice. Even if you don't use Atlantis today, even if you're using Drone or Jenkins or some other system, some of these best practices I think you might be able to take advantage of. One of the things that we do that's a little bit controversial is we run one Atlantis per AWS account because we like the idea of sharing nothing. So it also forces a workflow where an Atlantis or a pull request can only ever modify one environment at a time. And that's pretty nice from a blast radius perspective. Use IAM service accounts. So these are like STS tokens, the Amazon short-lived tokens. And those will give you access to AWS and be automatically rotated on an interval that you define. So like every 30 minutes, those tokens expire. So if you accidentally leak these AWS tokens, the fallout is limited. Use code owners. So all your code is in this Git repo. Now you can use a GitHub convention called .github/code owners, and it's a file. And in there you describe the paths and who has to sign off on changes. So if you have DBAs or if you have network admins or different teams within your organization, you can ensure that one of the subject matter experts signs off on that change. But you enable anyone to make the change, so that reduces the bottlenecks in the equation. If you're using Terraform, use TFRs for all your settings that are not sensitive. So don't put your passwords in there, but put your instance sizes or types or things like that. And many of you probably use Vault or Console today. We use Parameter Store, which is just Amazon's fully managed equivalent type of service. Not feature-wise necessarily, but we still get encrypted secrets, and we still have the ability to restrict those with IAM, and Terraform natively supports it. And now here for you, if you're using like Jenkins or Drone for Terraform automation, that's totally fine. But one of the things that we find really annoying with Terraform is when you see the plan for IAM policy document changes, it's going to be one line with 5,000 characters of JSON code that you can't unpack or unfurl visually. So scenery is a small little binary you drop in. It's a Go binary, and it'll unpack those IAM policy documents so you can see exactly what's being changed. The other thing is in Terraform, it's leaky. So the output sometimes might reveal some information you might not like to have in your GitHub comments. So to mask that output, we have a small little utility we call tfmask, and you can find that on our GitHub as well. So in the end, why do you care about all of this stuff? And I argue that why it matters so much for a business is what you want to do is enable teamwork and effective collaboration. And you want to eliminate the bottlenecks. You want to enable more people to be more productive. So GitOps is what allows us to stop living dangerously, applying changes on local workstations where there's no record of what happened, to practice total transparency in operations, enable team collaboration, reduce the total number of individuals who have to have access to environments altogether, which will increase your security posture, and ultimately improve your productivity, maintenance, and repeatability. So all the examples from this talk are available on our GitHub. If you go to Cloud Posse, we have our Terraform module for deploying Atlantis as an ECS task in your ECS clusters. You can find that there. You can join our community. We're over 600 members strong of active people doing awesome stuff with Terraform, Kubernetes, and DevOps automation in general. We have a whole bunch of other projects, like I said, over 300. Do check them out. And at this point, that's it, folks. Open them to questions. I'm going to check to see if there was anything submitted via the slides here. And there were none. Cool. So let's do this the old-fashioned way. Oh, it was not accessible. Fail. Okay. Yeah. Well, Atlantis couldn't help me there, I guess. So any questions that you have on the top of your mind right now? You.
Thanks for this talk. This is really cool stuff, actually.
Thank you.
I had a question about, because we're looking into solving this type of problem in our organization, looking at Terraform Enterprise.
Yes.
The first time I've actually seen this product, and it's very similar.
Yes.
So I'm kind of curious about the longevity of this
Yes.
open source project from your perspective.
Yeah.
Can you lighten up our
Yeah, so the question is, can we rest assured that this product is going to remain around given that there's Terraform Enterprise? And I don't know if you went to the keynote talk yesterday by Mitchell Hashimoto, founder of HashiCorp and CTO. But his thing was Terraform has two types of users, basically. You have the hardcore practitioners, the end users. And they're not trying to monetize those. And those are a very difficult group of users to convert because they typically want free things. I think there's always going to be a demographic for whom this appeals. Terraform Enterprise is solving this at enterprise scale with greater control over policies and enforcement than you can get simply by using GitHub and code owners. So I think this is well suited for certain kinds of organizations, but maybe if you're a bank, you're going to want to consider using something like Terraform Enterprise. Yes. Yeah, that would be totally fun. That would be a acceptable model. If you end up using Atlantis, there are going to be a few nuances there that are out of scope for me to bring up right now. But shoot me an email and I'll let you know what those are. Totally feasible. Would recommend it. It just comes down to how you organize your projects to achieve that. Yes. Yes. Oh, this is a great point. Yeah. So you have this plan that was generated. Well, a very important thing that I kind of glossed over in this demo and didn't emphasize, but is essential for working with Terraform or these kinds of things, and why I don't recommend using Jenkins or something like that other than Atlantis, is because what you really want to be doing is locking the project. So if you think about how Terraform infrastructure is managed, it's like a monorepo. We have lots of different projects and you surgically target one of those at a time. You don't reapply all of those projects every time because that would increase your blast radius. In Atlantis, it automatically locks that project for all pull requests. So now if somebody else wants to open up a pull request against that, that's fine. But they're not going to jack my lock, so to say. There is a process for forcefully releasing that lock, so you're not going to block teams and stuff, but at least you can therefore collaborate on this stuff without stepping on each other. And basically what it means is you got to rerun a plan, and then you... Oh, yeah, my point there is that you can run Atlantis in Docker, but you wouldn't run Docker in Atlantis. So to your, yeah, that was just that thing. Since we deploy it as an ECS task, that's just a good example of how it could be run as Docker. We've also run it in Kubernetes. What we don't like about running Atlantis in Kubernetes is you basically have this container you can kubectl exec into with administrative permissions, and that's kind of a deal stopper. But Fargate, you can't do that, so it's good. Any other questions in the back? Yeah, actually, that's a good question. That was a popular feature request, and that's how you can kind of emulate the same behavior of a traditional CI/CD pipeline, basically a compensating control. I think in the last 2 weeks, that feature has been merged. Another thing in my slides that was not clear was the Atlantis status on the GitHub pull request just showed one Atlantis line. Now they've decomposed that to plan and apply. So in your GitHub pull request branch permissions, you can require that the plan succeeds before anything happens, for example. Or you can require that the apply succeeds before you merge it, which is essential. Yeah. Any other questions? All right. I guess that's it. Thank you, guys. You're an awesome audience. I appreciate it. See you next year.
demo.
Good afternoon. I had a feeling that I wouldn't have any amplification, so I might just have to use my theater voice today. Because neither of these are actually amplifying anything. Hello. Maybe there's a volume switch. Are they coming? Because I'd like to start. Master is turned all the way down. Hello, 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 hello. Hello? All right, so, oh, magic. All I had to do was put it on my belt, and it started working. Okay, so welcome everyone to What is a Service Mesh? My name is Adrian Otto. I'm from Google. I work in the office of the CTO there. Now, I'm happy to be at SCaLE. I can say this is, I think, the third SCaLE that I've attended and the second that I've presented at. But I'm really happy to be here, not because of this presentation, but because I'm a California native. I was actually born in Santa Monica, and I lived here for over 4 decades before I relocated to go to the Bay Area. And so I've been around quite a bit. This feels like my stomping ground, and so it just feels like I'm home. So thank you for making me feel comfortable. All right. Oh, there's another California native in the room? How many do we have? Show me, like, how many are natives? Like, you were born here. A lot. That's solidly 40% of the room. That is awesome. And how many of you have been in California more than, say, 5 years? Okay. And so you consider yourself from California if you've been here for 5 years? Yeah? Okay. That's good. I always wondered, like, how long, because when I lived here, it seemed like there were no natives. It seems like I was the only one. And I would talk to people, and they'd be like, yeah, I transplanted here 30 years ago. And I'm like, are you from California? They're like, oh, yeah. And I'm like, well, how long is it that you can be here before you identify as a SoCaler? But, so anyway. Wake this thing back up. Okay, so today we're here to talk about Service Mesh. And I want to start by taking us back into history a little bit. The last 6 years, I think, have been particularly interesting. So if you kind of transport yourself back 6 years and you're in 2012, at that point in time, public cloud is just starting to become a thing. All right, people are starting to like trust it and starting to put like CI/CD workloads there and backup workloads and things. Not super serious stuff, but people are starting to really do public cloud for real. VMware is everywhere. Like every single corporation has VMware, and it's just virtualization is the thing in 2012. Around 2013, right, Docker announces their first release. A year later, Kubernetes comes out. A year after that, in 2015, Google donated Kubernetes to the Cloud Native Computing Foundation, which was pretty special, right? Kind of trying to build the open source community aspect and getting not just Google's point of view represented, but those of everybody else. Shortly thereafter, Envoy as an open source project was announced, and it has been categorized by journalists as a service mesh. Right? When it came out, it was kind of characterized in that way. A year later, Linkerd became part of the CNCF. All right, and Linkerd is about building service mesh as well. And then Istio comes out a year after that. And so this is, if you're just paying attention during this frame of time and you care at all about cloud native applications and about how they are set up, this is pretty confusing. You're like, which of these is the right thing? And what does it really mean? And why is it separate from, my container runtime, for example? To make things even more confusing, Google comes along in 2018 and they announce Istio and Knative at the same time, right? And they call Istio a service mesh, and Knative is all about running applications that are designed to run in event-driven architecture, the serverless style, right, in a way that is open and that you can run in your own infrastructure the same way that you would run it in a cloud environment. And about 2018, 2019, Istio starts building a following in open source to the extent where it becomes a real thing. All right, it becomes a critical mass where there's enough big companies that are using it, and there's enough work happening in the open source community that you're like, okay, this thing is for real and it's going to be around. So this is kind of the perfect time to fully understand what it is and why you care, and to start getting familiar with it. Because before now, I admit, that's a confusing history, but from this point I think things are going to start to become much more crisp. Okay. Now this begs the question, is a service mesh just frosting on top of Kubernetes, or is it actually something different? Is it actually something complementary? And if I do my job in this talk, you should walk out with a crystal clear understanding of which of those realities is true, or both. Okay? Now, how many of you, just by show of hands, think at this point, before I've said much, right, you think that Kubernetes is just frosting on top of Kubernetes? Just show me if that's what you're thinking. Okay. Nobody's raising their hand. Okay. Who thinks it's something entirely different that complements Kubernetes? Okay, I'm getting 10, 15% of the room. All right, and how many of you are here and you're just happy that you're going to find out and you're going to walk out of this room knowing? Okay, the rest of us. Cool. So I promise to make this clear. Okay, so I don't like boring talks. I like to tell stories. I like to do funny things. And today we're going to try to do something different. I'm going to do an audience participation exercise. Now, before all of you came in, some of you, I went out and I found a couple of volunteers in the audience to help me. Now, because this is Los Angeles and we have the entertainment industry, I'm sure you've all seen a set of a movie or a TV show before, and you know that the actors don't actually know all of their lines all of the time. And so what they do is they hold up cue cards to signal the actors and actresses to say the right thing at the right time, okay? And they even have like a person whose job it is to hold the cue card, okay? And that's what our volunteers are going to be doing today. So we have 2 cue cards and my 2 volunteers, and when it's time, I'm going to be signaling, so let's try. Let's just practice, okay? So get your cue card ready, and you're going to hold up your cue card, and all of us are going to be the actors, and we're all going to say the word. Okay, that's the line. That's only one line you need to know. I promise not to, yeah, there we go. Okay, he's going to be sitting during the talk, so it's not going to be quite as high. But when you see that, you're going to say the word running. All right, and we have a second volunteer who's going to have the other cue card who has the other line, and the other line is connecting. Okay, and this is important to my talk, that we're all going to be able to say our lines to make this interesting. Okay, are you with me? Let's start. Now, before we start the whole cue card thing and get that going, I want to take you back in time, a second time. This slide is something that Google uses all of the time to talk about how wonderful containers are, okay? Now, the narrative goes something like this. We use containers, we start 4 billion of them a week, it's essential to the way that we do our system design. And the coolest thing is, since 2004, our jobs have been going, breakneck skyrocket pace, but our ops teams have only been growing by 1/10 of the size. Fantastic. And it's absolutely true that containers have an awful lot to do with that story, but it's not the whole story. There's more. Okay, and service mesh is part of that additional story, and I'm going to explain how that contributes to this kind of a result. So we'll see this slide again. I'll come back to this. Okay, so has any of you in the audience read a research paper on either Bigtable or MapReduce? Okay, you guys are probably in the ACM or something. You're reading all the papers, or these are particularly interesting papers. For whatever, this was 15 years ago that Google started publishing about the computer science innovations it needed in order to make its search engine possible. Okay, and it's about Google staying truthful to its mission. Okay, if you read the Google mission statement, it's to organize the world's information and make it universally accessible and useful. So we thought that part of making that information accessible and useful is about sharing with the computer science academic community what it was that we had actually done in order to figure this out. Okay? Now, what we didn't maybe anticipate at the time that these were published was that there's an awful lot of other smart people in the world who've come along and implemented open source software that actually do those innovations. Okay? The trouble with this approach is that it takes time from when you publish research until the time you've got software developed and that it's actually working for everybody to benefit from. So if what you truly want is to fuel innovation, then you need a better way. And so we started doing things, and in all truth, we still publish research papers all the time. But what we also do is we take what we learn from operating systems at massive scale with billions of users, and we take those lessons and we codify them into open source so that communities can benefit from them as well. And in addition to the lessons we're learning, right, community is going and contributing as well to make it even better. And so it's a better approach than just, hey, I had a great idea and I wrote it down, but here's something you can actually use. We did this with Kubernetes. And I think it's probably safe to say in 2019 that most of us feel comfortable with what Kubernetes is all about. Are you ready? Get your cue card ready. Okay. Kubernetes is about running, with me please, is about running applications. Thank you, you're awesome, you're all actors. Did any of you star in a school play, or you're actors on the side and you're just doing tech as a thing, to pay the bills? You're awesome, great. Okay, so it allows you to run applications on your own equipment or in the cloud of your choice. And it's all about the running of those applications, okay? So, Kubernetes is only one of a number of open source projects that's following the pattern that I'm talking about, okay? All of these different open source projects all fuel innovation in their own way, okay? And they're all kind of related and working together. So Kubernetes is one of them, but there's a lot of others here. Now, I hinted before that there was something special about what Google was doing with how they actually run containers that contributed to the lift between these two lines, okay? And I have a very strong belief about what that major contributor is above and beyond what you get when you run containers in Kubernetes, okay? It's this. It's the idea of service mesh. Now, I first kind of became aware of the service mesh concept before I ever worked at Google. It was around, maybe the time, the 2015 timeframe when Linkerd was joining in the Cloud Native Computing Foundation, and the term service mesh started to be bandied about a little bit, and I saw definitions that looked an awful lot like this. And in all honesty, the first time I saw this, I didn't quite get it. I get the words, I know what the words mean, but I didn't really get it. And I've, kind of over time learned to get it more and more. And what I'm hoping I can do is, if you're looking at this for the first time and this is not truly resonating with you, you're like, what's an application network function? Or why does it matter that it's transparent and language independent? If that doesn't make a whole lot of sense, I'm hoping to just shine some light on that and get you past the point that I was when I first saw this concept. So the engineers, they pull this out and they're like, service mesh is this. And I'm like, yeah, but why? Who cares? Now don't worry. So I've been talking about Istio and service mesh as synonyms. So if you want a simple definition of what is Istio, the short answer is that. Okay? But as Billy Mays would say, wait, there's more. Okay? this is where I hope I can just blow your mind a little bit. Okay? So we've talked about the applications running in Kubernetes, and then I introduced Istio. It would be natural to think that these things are designed to work together, and they are designed to work together. But Istio is also designed to work with or without containers. Okay? And it's also designed to be used with or without Kubernetes. So that's what this service interactions across container and VM, right? That's why this caveat is thrown in here. This little extra nugget is in here because it's not just frosting on top of Kubernetes. It is a thing that allows you to do hybrid communications. I'm going to get into all the cool hotness about it in a minute, but take this away, it is not just a thing that relies on Kubernetes and gives you some additional capability. It is something that is designed to stand alone and combine a wider environment that is not necessarily cloud native. Okay? It'll help cloud native applications, but it will also help ones that are not. Okay, so I'll come back to this. Now, we've already covered that Kubernetes is about, hold your cue card, running applications, but Istio is about connecting applications. Okay, so the thing about the concept of a service mesh, like Istio, is that once you have an extensible, configurable, transparent network connecting everything together, suddenly all sorts of amazing things start to become possible. Okay? So a service mesh is like finding a key that opens up a power-up in your cloud-native world. Okay? That's how exciting it is. So, time for audience participation. Got your cue cards ready. Kubernetes is about running applications, and Istio is about connecting communications. Okay. Now, if you're happy that you've understood the difference, everybody can leave now. Like, the good stuff is coming, but like, I've done my job. That's it. Okay, now you really want to hear more, don't you? Okay, so when I was first kind of fathoming the concept of service mesh, something I did not realize, it was not obvious to me, was who cares? Now, if you're a infrastructure, person, you're responsible for servers and networks and ports and machines and power and all this kind of stuff, you get kind of things and how things work at a cloud management layer, and Kubernetes makes sense to you. Like, you get this. But if your job is a service operator, right, your job is to make sure that this thing is always running, and the right version of that thing is always running, and the right kind of clients are connected to the right kind of thing, and the people that are in the right regions are connecting to the right regions. You are not the same person necessarily as the person who's responsible for the infrastructure. You care about the actual service that's being delivered. Okay, and so service operators and SREs, Istio is really, really useful. For infrastructure managers, Kubernetes is more interesting. So depending on who you are, you might gravitate to one or the other based on this. Okay, so be careful not to think about this as a layer cake. Now, my colleagues will describe this as building abstractions up. Okay, they'll talk about Kubernetes is an infrastructure that allows you to run service mesh, which allows you to do, native. And look, that claim is true. But these things are for different audiences, right? There's the infrastructure people who care about this, there's the service operators who care about this, and the developers care about the interfaces to do their next generation system architecture, and to do that in a way that could be a serverless design if they'd like. All right? So I keep saying it's so awesome. What is it? What is the awesomeness? So there are 3 areas of value that Istio is providing. The first is what we call uniform observability. Now, each of these things, in all fairness, each of these areas could be a different tool There could be a different solution for each of these three areas. But Google kind of has this opinion based on that experience I was talking about, that these three areas should actually be solved together as a set, not individually. Now, usually the right answer is do one thing and do it well. But sometimes the answer is not. And this is one of those cases where these three things are all enabled by the same innovation. They are all very different benefits. And this is one of the problems with service mesh, right? There's so many things that are compelling about it. It's hard to put it all in one idea, right? I like to talk about this all the time. Like, we can remember like 6, 7 things, no problem. And once you start listing more than 7 things, we start to get really bad at remembering the things that are beyond that on the list, right? So like when you go to a service mesh talk and they're talking about all these wonderful things that service mesh can do, and it's like boom, 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 mind-blowing, great, awesome, cool hotness. And you're like, well, all of that? That doesn't make sense to me. Okay, so if you break it down into these three things, there's uniform observability. That's about looking at how my service is actually running. All right, what is actually happening? What services are talking to what services, at what query rates, at what health, at what error rates? What things depend on what other things? Where is my application busted right now? In a complicated distributed application, right, if you're using microservices at any scale, that is actually a rather hard problem to answer. It's a hard question to answer. Okay, and Service Mesh gives you a view, a point of view, that starts to make that much easier to determine. All right, the second is operational agility. This is about doing things like, and I'll talk about this more in a subsequent slide, but it's about what things are going to connect to what other things and being able to control that using a policy. How much traffic is going to go to this part of the application versus that part of the application? This version versus that version. This client has this behavior, this client has this other behavior, right? And if you're a system operator, a service operator, that's really important to you, whereas the developer is less interested in that. The developer is just making the new features, right, and fixing the bugs and the things that are there. They're less concerned about the experience of all the different users. Okay, operational agility. And then the third is my favorite, policy-driven security. Now, one of the things people love about Kubernetes is that it gives them the ability to run their applications on different clouds in a deterministic way, right? You're going to get the same runtime behavior in your own environment as you get in cloud environments, as you get in another cloud environment. Now, that's not 100% true, but it's close, okay? So if we can agree that you get a similar behavior between all of your runtime environments, wouldn't it be great if you wanted to express security policy in a way that would also work regardless of what your environment is? And that is not true today. If you are using the advanced features of your local environment and your cloud providers and you're doing it in different places, the way you express security is different in every environment, and that is annoying. So this gives you a way to do it in a deterministic way, right, using a simple expression of what the policy is that can be applied in all the different places you run that application. Okay, now I talked about SRE a moment ago. SREs care about something called an SLO. Does anybody know what an SLO is? Holler it out. Awesome, we've got an SRE in the room. Service level objective. Okay, service level objective is about measuring the performance or the reliability of a service that you're providing. Okay, it's a way of verifying its quality. And it turns out that there's this set of SLOs that you start seeing again and again and again. And it turns out that Google has these things that if you read the SRE book, they're called the golden signals. And these are 4 signals. They are request rate, error rate, latency, and saturation. It turns out that request rate and error rate and latency can be measured the same way for every single application. So why should you implement SLO monitoring individually for every single service if there's a way to do it exactly the same way for everyone? Okay? This is one of the justifications for solving these problems as a set, right? If you can measure these golden signals universally in a way that's, first of all, transparent to the developer, and second of all, just happens automatically, all of your services start to have these golden signals measured, okay? Assuming you're running them through Service Mesh. And if you do, then you can start building tools that give you a sense of the relative health of all of these different services, no matter where they are in your environment. That starts to become pretty powerful. Okay, so Istio provides you the ability to measure these, at least the top three of those four golden signals, right? The request rate, the error rate, and the latency. It just does it for you. You don't have to take any effort in order to get that. Now, there's a fourth golden signal called saturation, and the reason why your service mesh is not measuring saturation is because that depends. It depends on how much capacity you have. It depends on the way that your hardware behaves. It depends on the way that your software is actually designed. Okay, and so implementing a saturation SLO will be different from service to service, but the other three are all the same. Okay. So the second area I talked about is operational agility. Now suppose you've got a new version of a service, okay? It's got these new capabilities, or it's more efficient, or something about it is better, okay? And you want to start introducing this new service into your production environment. Now, a lot of people, what they're doing is they have a test environment, they try stuff out, they simulate, they put it into a staging environment, they try it out there, maybe they put some traffic into the staging environment, more simulation, more real, and then they gulp down and they put it into a fraction of their production environment, which is usually like half of their production environment, or sometimes all of it. And the trouble is you take a risk when you go from staging into production. That might be very nice not to take that much risk. Maybe you want to take less risk. Okay, and so wouldn't it be nice if you could make a policy that says, okay, I want 5% of my traffic to go to service B prime, where 95% of my traffic remains going to the previous version of the service. Now, you might be thinking, well, doesn't Kubernetes already do that? Kind of, yes. You can route between node pools, but it only evenly distributes traffic between them. So in order to actually implement this, you need 100 node pools, and you're going to set 5 of them to take new traffic, which is really a clumsy way to accomplish this. And the configuration that's required in order to achieve that is actually not very simple. So if you could just have a couple of lines in a configuration file that would affect how your service mesh behaves, all of a sudden, this becomes really easy. Okay, let me give you another example of the operational agility. Suppose I put a feature in my software that only users of Apple phones care about. And if I do that, I don't want every single user to route to this new little bit of my infrastructure that's running this new code. I just want the ones who have that device type to route to that new thing. And if it turns out it's a colossal failure, great, I'm going to roll that back. But I haven't exposed the entire world to that. I've only exposed the users of that platform for which this feature is designed. Okay. So you can do all kinds of really cool stuff like this. Another, besides just changing versions, another cool thing is when you have a complicated distributed system and you've got services connecting to other services over the network and something goes wrong with your network, you might have code in your microservice that is designed to retry on a timeout or retry on an error after some delay. And what the unintended side effect of that is, when the network is malfunctioning, all of a sudden you're generating more traffic and you're exacerbating your problem, and it gets harder to solve the problem that you originally had because of the retry logic that's actually built into the microservice. So what if you didn't do that? What if you took the retry out of the microservice and you just say, try once, and you configure the service mesh to do the retry transparently for you in a way that is completely invisible to you? That way, you would have the ability to change that behavior in the mesh should you need to. So if your network is freaking out and one service is getting clobbered by another because of retries, you can quickly change the retry policy and make it stop. We do this all the time when we have problems. We change the retry policy, dial it way, way down, wait for things to go back to sane again, and then try to dial it back up again. And having the ability to do this, again, super powerful, very useful, especially if you have a big network with a whole lot going on in a very complicated way. And you can change the retry policy based on channel attributes again. So if you're like, I only want to change the policy of this service affecting this service rather than the policy of everything globally, you can do that. Okay. This is all about operational agility. There are other examples, but I think these kind of illustrate the point. The third area that I said was my favorite was policy-driven security. Now, if you simplify your microservices so that they don't do encryption, and you rely on the service mesh to do all of the encryption, your life gets a whole lot easier. You still get secured communication from one service to another. I'll show you a diagram of this to show you exactly how this works. If you just trust me for a moment, right? You get secure communication from one node to another, but you don't need to do any certificate management. You don't need to do any revocation lists in your applications. You don't need to do any updating of those things, right? How many of you had to change your code when Heartbleed came out? My bet is all of you. My bet is anyone who had a production application that was doing SSL or TLS and Heartbleed came out, everybody needed to recompile everything and redeploy it. Now, if you had the ability to do this in the mesh, right, and you're expressing a policy that says, I require mutual TLS between all of my services, then you have assurance that the only way that service A can reach service B is if it has valid credentials and it's doing it over a secure channel. It's impossible for the two things to actually interact without that in accordance with that policy. Okay, and I talked before about this being portable across your different environments, right? You implement this in your own environment, you go and you use it in a public cloud, you go and you use it in a different public cloud, you still get the benefit of this. Now, let's take a look at what services make up Istio. Now, in all of those early talks that I went to learn about Istio, this was always like the only slide. And if you only look at the architecture slide, you don't get the whole picture. So I recognize we're a room full of engineers. How many of you are engineers? Just show me by raising hand. 90% of the room is engineers. You have to see an architecture slide, and I'm going to show you that, okay? But I need to say a whole lot more than just showing you this, because just knowing what's inside of it doesn't really explain why it matters. So Istio is a way, like I said before, of connecting services together. This is expressing service A on the left and service B on the right. And these things are connected together with mutual TLS. And that is enabled by a set of 4 different services that are part of Istio. Okay, Istio is a control plane for managing and enforcing all of this. All right, so here are the 4 parts. There's something called Pilot. Now, Pilot is a service to configure and distribute the service communication policies. All right? You can think of it as like it's the configuration master for all of the Envoy proxies that do the communication between the services. Okay? So rather than having a single copy of the configuration that everybody is centrally referencing, you instead have every single participating node in the entire system has a copy of the configuration, and this is the thing that makes sure that it's the right configuration, right? It's the right version, and all of these things are synchronized, and it's taking care of all of that for you. Okay. The second thing is called Mixer. Now, Mixer is the thing that makes this a platform. Remember in the definition before I was saying it's a platform? This is where the integration comes to make it a platform. Okay, and I'm going to show you more examples of how Mixer actually works, but it's where you can collect, like, remember I was talking about those signals, right? What is the activity level between these services? How healthy are they? All of that is being collected and pushed through this thing called Mixer, and Mixer is extensible, so you can plug in, suppose you already have a big investment in something like Datadog, and you want to hook that in. Well, there's an Istio adapter for that. You can just plug that in and continue to do things the same way you used to do them. Right? I'll come back to this again. Okay, then there's Citadel. Citadel you can think of as, this is enabling both auth-N and auth-Z through mutual TLS, but with built-in identity management. Put another way, you can think of it like it's a certificate authority for all of your SSL, right? That's automatic, that you don't worry about. It just happens. Everybody gets valid certificates. All the configuration of all the mutual TLS is all set up. All the enforcement of that back and forth. I'll get to the non-replayable identity thing in just a minute. But Citadel is what makes all of that possible. So this is about the secure communications. All right, and then there's a final thing called GALI. And GALI is the user config, it's the validator, right, for the user config for the other control plane services. And over time, GALI is going to become responsible for the top level configuration, ingestion, processing, and distribution component for Istio. All right? So GALI is going to become more important over time. Right now, what it's just doing is verifying the configs for all these other things. All right. And you need this control plane in order to have all of this magic that I'm talking about, because distributed systems are complicated, and something needs to keep track of it all. All right. Does anybody know what kind of motorcycle this is? This is the first one of its kind I have ever seen. That is the coolest sidecar I think I've ever seen. And one of these times I'm going to give this talk, and somebody is going to know what that motorcycle is, and I'm going to learn something. What is it? BS. Well, no, I think the badge has more letters on it than that. I can't quite read it. Like if I zoom in really, really, really close and I look at this, I think it might be a Triumph, but I don't know. One of these days, somebody's going to have one of these bad boys, and they're going to tell me what it is. All right. So the purpose of this slide is to talk about the concept of sidecar. Now, how many of you already use sidecars today? Okay, awesome. Less than 25% of you are using sidecar pattern. Sidecar pattern is a way to tie something to a pod, an extra thing, a logger or an auditor, or in this case, a service mesh proxy, okay, in a way that doesn't require you to change the configuration of your pod, but adding a couple of lines to say that you want this sidecar to be stapled onto your pod. All right? So if you're in a Kubernetes environment and you're using Istio as your service mesh, your pod descriptor, right, this is a YAML file that just describes how you're going to run your application within Kubernetes, has a couple of additional lines in it. It's that easy to turn this on in that kind of an environment, which is why Istio was first presented as works with Kubernetes, because it's so easy to turn that on, right? Now, you can also use it without the sidecar, right? You can always just install the proxy and provide the the IP tables rules that are necessary to do the traffic intercept on a VM or another environment, right? But it's just really easy to do within Kubernetes. All right. So let's go into Pilot a little bit more. So Pilot is responsible for configuring all of those Envoy proxies that are in all these sidecars, right? So you start doing this for all of your applications. Every application that you want to participate in the service mesh, you add these lines to your pod descriptor, and now you start having these sidecars popping up and connecting all together as a mesh, right? Pilot is responsible for doing that distribution of that configuration to all those sidecars. Now Mixer, I told you this is an extensible component that is responsible for keeping track of all the things that happen between your microservices. Now, pictured here are some adapters that are for Google-related things, but there's a whole community of other plugins as well. And if you want to hook into an existing system, you can write your own plugin. It's not that complicated. You can just connect. It uses a gRPC interface. It can run out a process. It can be called by the mesh externally. You don't have to build it into Istio if you don't want. Now, if you do build it into Istio and it becomes runnable within the proxy, you get really high performance, right? Because all of those checks, whether you're doing access control or you're doing some kind of a decision about a quota, right? If that's happening in process, the tax of the performance tax of the proxy handling that connection is very low. Whereas if you start calling out to these external things, you start to trade some performance for the capability. Now, in my mind, getting all of this is totally worth a little bit of performance cost. But in cases where you can't afford any degradation in performance cost, you can always put a Lua script into the proxy itself and do it in process. Okay. Citadel is responsible for all of that authentication. I told you that I would describe this deeper. So suppose you've got service A that is communicating with service B. From its perspective, it's just connecting directly to service B. But what's actually happening is that proxy is intercepting it, and it's using a non-replayable service identity that is bound to that TLS channel. So you've got this communication channel between the two services, and you use a non-replayable service identity. Why does that matter? It matters because if you have a service that becomes compromised and somebody gets that service identity, it is not a reusable bearer token. It is something that only works one time. So if you intercept it and then you go somewhere else and you try to use it, you can't use that again. All right? So even in environments where you don't trust the network and maybe you don't even trust the services, you can still achieve higher levels of security resiliency by using this. And this is actually pretty hard to do if you need to modify all of your different services in all of the different languages that you write them in. Chances are you don't have a single library that's just going to answer this globally for you. But if it's in the mesh, you can. Okay. Now, this service level authorization, some of it is happening, what I've described as things that are happening down at the network level. You basically get that stuff for free. There are things that you can actually cause the application to do to get even higher levels of control. But there are things that you can enforce through the service policy, or the actual policy-driven security. So, for example, if you have a JWT claim that claims that the end user of this application is in fact this individual person, the service, now that gets passed through the entire mesh, and the service, in addition to what it does, can validate that it's actually being acted on by this particular individual. And policy can be made by the mesh, all right, based on the things that are getting passed through by the application itself. So when remember I had service A and service B? If service A is sending a JOT token through to service B, the mesh that is responsible for service B can enforce against that token. Is this making sense? Good. All right. So imagine you've got a service with personally identifiable information on the right, okay? And you've got a customer service tool, we'll call that case tool, on the left. And the case tool has to be able to collect the personally identifiable information so it can be presented to this particular authorized user. Okay, this is what it's designed to do. And we've got this mutual TLS trust between the mesh nodes, right, between these two sidecars. And suppose you've got Joe, who's an authorized user, right, who can interact with the case tool, sends the JWT claim through service case tool to the service with the PII, and is allowed to do that. Say I take the same authorized user and we build another service called BI tool. But BI tool, in accordance with this policy that is expressed on the left, is not allowed to get PII out of that service on the right. So even though he's an authorized user, it is a perfectly valid identity, and there is still trust between the BI tool and the PII service, it's still prohibited. And this is a level of control, again, you can totally do. But this is really hard to get right across a complicated environment that's written in a whole bunch of languages, a whole bunch of different versions, okay? This starts to make it uniform. Okay, so I think I've made the case of why it matters. Now let's talk about how it actually works. So we're going to trace the life of the query, right, of a request through the entire system step by step, and we'll talk about what happens at each of those steps. Okay, so in this example, we've got service A and service B. Both of them have sidecars that are running Istio, right? Istio's got a common control plane across all of the nodes in the mesh. When it comes up, Envoy gets set up with the configuration from Pilot, like I talked about, okay? And it gets its cryptographic identity from Citadel, and that's done in a safe way. Okay, so now we've got these things that are allowed to communicate securely. Great, let's see what happens once they're up and running. Suppose service A wants to talk to service B. It just makes a connection to the address of service B as if it were just making an ordinary TCP/IP connection. Okay, it doesn't need to be doing it over an encrypted channel, right? Because the mesh is handling that for us. It's just making a connection across. And that connection is getting intercepted by the proxy on the left. Okay? That is where it gets encrypted with that identity. That gets forwarded across to the second proxy in accordance with the configuration. That second proxy then hollers down to Mixer and says, this thing is happening right now, right? So this is a way of like collecting logs without having logging in any of your apps, right? So your policy engine and your quota adapter have an opportunity to act, to accept or deny this at service B, right? So if service A is only allowed to interact with service B a certain amount, right? This is an example of a quota scenario. You can block it at service B if it's been too busy, for example. Okay? After that, the proxy at service B, or in the sidecar of service B, forwards it to service B. So from service B's perspective, it's getting a message from service A. From that point, the service B generates a response, sends it back to the proxy. That proxy sends it back to the other proxy on the other side of the mesh, decrypts it. I've gone backwards, hold on. There, decrypts it, and then after that happens, again, service B's Envoy sends signals down to Mixer to say, okay, that happened, here was the outcome of that. And then service A's proxy then delivers that response back to service A. So service A thinks it just got a response from service B, even though all of this stuff has been happening in between. Okay. Then, after that's happened, service A's proxy sends down to Mixer, this happened and this was the outcome. Okay? So, the thing that you can do once you've got one of these environments up and running is to start to rip all kinds of complicated stuff out of your microservices. Suppose you have service A and service B. No, sorry, two versions of service A. Version 1 and version 2 something, okay? Version 1 and version 2 something are both using a client library, a different version of client library, to do the same thing. Suppose it is encryption, right? In the old world, before service mesh, suppose you have a vulnerability, a security vulnerability that you have in the actual library. Now you've got to recompile service A against whatever version of the library and its API that it was designed against, and then recompile a different one against a different library version, which you also need to patch separately from the first one, because the different versions aren't guaranteed to have the same patch, right? So now you're doing this whole mega patch exercise everywhere, where every single version of every single thing that you run now needs to be changed, okay? If I can make that go away, and you just handle that in mesh, and all of the services just don't have that library at all, then updating that starts to become very simple. All right. Let me give you another example, hybrid use case. Suppose you have an old, crusty database running on some system that everybody is terrified to touch. You know what I'm talking about, all right? It's that service that you're running that's super important, that's been around forever, that like nobody is brave enough to go in and enable TLS on that thing. Nobody. Like nobody's gonna touch that. Like no way. But if you could put a mesh in between these things, right? You could start to secure the communication between the service and that old crufty database. And you could do it without changing the protocol at all, right? So now we get the behavior and the security benefits of running the mutual TLS between this old crufty thing and this, hot new cloud native service, but without actually disturbing this in the way that you're afraid to do, or that I would be afraid to do. Any of us could honestly say there's something they would rather not touch. All right, service mesh to the rescue. So the more your system handles in a uniform way for all of your services in the entire system, the simpler you can begin to make them, right? When they're simpler, you can do them more easily. You can iterate on them more quickly. You can make them secure again faster, right? Everything gets better when things are simple. So you can implement security policies that control what services can connect to what other services at a level of control that's much harder to do otherwise. You can do things like monitoring and logging. Like, for example, suppose you just want to look and say, what services does this service use? Seems like a simple question, right? And if you ask an engineer, what services does this service depend on? You'll get an answer. And 90% of the time, that answer is wrong. Because even the person who created that doesn't realize that after the time that they created that, something has changed, and now it depends on a whole lot of other things. Or he or she says it depends on something, but that thing actually depends on a whole bunch of other things. Wouldn't it be nice to be able to visualize what all of those relationships actually are, so that if you're going to change something way up here, you have a sense of what the impact is going to be down there, right? That is why Google got this lift. That is the reason, right? The services can be created so fast. It's the reason that we can make new versions and new features so fast. It's because we're not doing all the hard stuff. All the hard stuff is done. Okay, and service mesh is a huge part of that. And it's not just containers, right? It's not just magic orchestration, right? It's something more. So, cue cards ready. In review, Kubernetes is all about running applications, and Istio is all about connecting applications. You've got it. And now you know why and why you should care. So, if you want to try this, I recommend this code lab. This is a totally like Google Cloud hosted thing. You go to this code lab, you can set up Istio yourself, and all of these claims that I'm making about how magical all of this is will start to become more clear, right? You'll see how you actually enable Istio in a cluster. You'll see how you turn it on a service-by-service basis. You'll start to see how these things interact. You can start to express policy on top of them. And then you'll start to be able to decide, you know what? I'm going to stop doing all the hard stuff, and I'm going to let Istio make this easy for me. Thank you for giving me your attention for all this time. Thank you to my volunteers. A round of applause for my volunteers. In true Los Angeles form. Thank you. I'll be around if you have any questions or want to talk. Thank you.
so I'm gonna just use the mic because it's gonna be recorded, I guess. Okay, this one's better. So yeah, this can be vaguely even interactive. So I'm going to talk to you a little bit about managing MySQL as well as MariaDB server in the hosted cloud. MySQL users? MariaDB user? No, okay. So in a consultancy, doing community, developer relations, HA, scalability, managing remote teams, as well as market entry. Doing a lot of MySQL, including today morning's panel. And I can definitely talk to you about VC versus non-VC backed company and engineering decisions that go with it as well. This is generally the rough agenda of what I plan to cover today. Basically, MySQL as a database as a service offering, your choices, considerations, the variants of MySQL that are available. So if some of you were here on maybe Friday, you would have gone to some of these MySQL 8 sessions, and MySQL 8 is awesome with GIS functionality, JSON functionality, and so forth. And can you use all of that functionality here? Obviously, the costs, and these costs, they keep on changing every time. So if you give this talk every year, for example, you would end up having different rates, and again, depending on which time of the year. How you manage, observe, scale, HA, security around it. Security tends to be usually by the platform itself. Backups also tend to be managed by said platform. So database as a service is basically SaaS for databases, so software as a service. The old way was you decided, hey, I'm going to make a new project, like, I'm going to make the SCaLE 2020 website. Then you go get someone to approve it. You order your hardware, you rack and cable it, you connect it to your network, you install the OS, configure it, start it. It takes several days, maybe even weeks. Nowadays, you just whip out your credit card, and you get started fairly quickly, on demand, no installation, no configuration, nothing for you to do. It's pay-per usage, typically every hour. You can even get free tiers. Every cloud provider offers free tiers. So if you're just getting started out, the free tiers are probably good enough for you. And you don't have to maintain, upgrade, or administer the database. So you don't have to be a database administrator or an expert in MySQL or MariaDB. You could just be a developer saying, I need access to a database, give me one now. And really, it is as simple as entering a card number and then using the GUI or calling an API like using the AWS EC2 route instances scenario. So why use a database as a service? Typically people say, hey, we'd like to, get more because we're going to get a traffic spike. Also, you don't maybe have a lot of DBAs, so you want to basically optimize for operational ease. So Indeed.com likes to keep track of salaries in the US, and the average salary last year was $106,000 per annum for a database administrator who knew MySQL. And that was, compared to the previous year, $91,000 per annum on average. And it's not uncommon to see these DBAs getting 150K, 350K if you're based in the Valley. So you can totally have lots of rapid deployment and scale out, but again, I highly recommend you take a look at the limits your database as a service provider provides. So like RDS from Amazon, for example, tells you have 40 instances per account, after which you need to actually apply for more. And some of them take time. Like sometimes to create a new instance, it can take you like 5 minutes, 10 minutes. Sometimes it's fairly instantaneous. Again, very much dependent on your cloud provider. So I'm only going to focus largely on RDS, MySQL, and MariaDB. RDS Aurora because I presume some of you may be interested in using it. Google Cloud SQL, Azure Database, which is maybe the newest kid on the block, and then Alibaba Cloud, and their products are called Aspara DB. Oracle Cloud MySQL totally has a service, but I've seen no real usage of this anywhere. In fact, a few months ago, there was an article in The Information, which is a subscription-only website, that stated that Oracle salespeople were trying very hard to flush the cloud service down your throat as part of a maintenance contract because they were getting better commissions on that. So even if you didn't need the cloud service, you were getting it. There are obviously more. Jelastic is a good example of one, which is a PaaS offering MySQL as well as MariaDB Server. ClearDB used to be the Microsoft partner of choice, as in you could use them with Azure, but now Microsoft themselves offer said service, so really it's good for Heroku. And then Joyent, of course, even offers an image for things like Percona MySQL. And you'll be surprised to note that Percona MySQL, while a very popular branch of MySQL, is not offered in any of the clouds, in any of the major clouds. You only really get MySQL or MariaDB. Pivotal also has something called Cloud Foundry, and that's again a MySQL PaaS solution, platform as a service. And they've got two variants of this. The version 1, which they are now calling Legacy, is based on MariaDB 10.1, and it comes with Galera cluster. Now, that is the idea of using virtually synchronous replication, where all nodes are equal, and especially upon commit time. MySQL for Pivotal Cloud Foundry version 2, which is the current version, actually makes use of Percona Server 5.7, and this one makes use of standard asynchronous replication, which is what they refer to as leader-follower, as opposed to master-slave, which is the MySQL term, which some now deem offensive. So leader-follower is the idea now. Now, Cloud Foundry, of course, works with pretty much every infrastructure as a service platform out there, be it AWS, Azure, Google, including OpenStack and vSphere. And I guess the significant difference here is that there's a difference between running asynchronous replication in the version 2 product and running fully synchronous replication, which is in the version 1 of the product. Now, if you sell a highly available MySQL, but you don't tell people that you're running fully synchronous replication, Galera makes use of something known as optimistic concurrency control, and it also will accept a transaction on a node, and when it's time to apply it on said node, it then starts applying it across all the nodes. And now if you happen to have a schema with a hot row, for example, it will actually ask you to roll back. So that you need to actually set up the retry auto commits so that it can keep on retrying, say, maybe up to 5 times. This, of course, is different from asynchronous replication, in where the leader gets a transaction committed to it, but the follower does not necessarily get said transaction either. It could actually be lost if the leader happens to go down for whatever reason, which is why MySQL also has something called semi-synchronous replication, which means that at least one follower will get said transaction. Now, most cloud platforms do not enable semi-synchronous replication. They all prefer their own variant, with the exception of Google, and we'll get to that later as well. Red Hat's been really making a good push around OpenShift, and there are variants, of course, for the online community version and enterprise edition. If you want to get more modern releases, naturally the online community version is better. However, you'll note that only MySQL 5.6 and 5.7 and MariaDB 10.0 and 10.1 are supported. This is missing MySQL 8, which has been released for about a year now, and MariaDB 10.2 and 10.3, which has been released for a year and 2 years respectively. So these cartridges need updating. Now, cloud services, naturally, I'd say beware, because sometimes they can disappear with 2 weeks' notice. Sometimes they disappear overnight, even if you happen to see them at a trade show. So The ones that we're going to cover, of course, are fairly large. They're all probably backed by public listed companies, so they're not going to disappear overnight, which I think is good. HP, for example, also had a cloud service based on OpenStack. However, they also decided to stop offering it because they'd realized that competition was pretty rife. However, we did get a bunch of useful things that HP managed to sponsor, including things like a utility user, which basically allows administrative actions to happen upon a database without giving that user access to the schema. So there's good separation of privileges. The ability to enforce a storage engine to say, look, I only want you to use InnoDB and nothing else. If you manage to use another engine, no warnings, just fail. Also, the ability to prevent load data in file and select into out file. Lately, you must have read in the news that there have been security issues where people can exploit MySQL arbitrary file reads, and you can get lots of rooted servers with an insecure version of adminer software. And that was basically making use of load data in file. And this feature, for example, is extensively used in things like Google Cloud SQL, which actually disables load data in file. Also, the ability to restrict the number of binary log files. Because you are launching up cloud instances and it's a shared environment, you can't affect other tenants if your log files, your binary log files grow very large. So you can actually restrict the number of binary log files to say, like, if you have a 5 GB instance, you don't want your bin logs to be larger than, say, 4. Alibaba has been making a great push. It's not very popular in North America, but I'd say it's definitely a serious contender. The Aspire DB for RDS obviously does MySQL and MariaDB. They also do like things like Redis, Postgres, MongoDB, and it's naturally cheaper if you host it outside of China. But they have data centers in places that you would not normally imagine would exist. And if you're going to do any business in China, they have China Connect, and you really want access to that. AWS was the first service offering to offer MariaDB server several years ago. And now you can find it pretty much everywhere else with the exception of Google Cloud. And there are some cool things you get with MariaDB server. Like if you do show global variables, for example, you get things like access denied errors, which is useful for a cloud-based system. How much memory is being used, rows read, and so forth. Things that you don't see in show global variables from MySQL, for example. When it comes to regions and availability zones, it's standard to understand that a region is a data center location containing multiple availability zones, and an availability zone is isolated from failures. So a region is basically a collection of zones, and a zone is an isolated location within a region. Google follows what Amazon does. They just call it a zone. Alibaba Cloud also basically tells you every zone it's got independent power grids as well as networks within said region. And of course, the network latency is going to be within the same zone is much shorter. Azure actually takes this a little further, where each zone is made up of one or more data centers that are equipped with independent power, cooling, as well as networking. And you have a minimum of 3 separate zones in all enabled regions. Now, this is not true with Amazon, for example. So to know if Amazon has got a minimum of 3 separate zones in one region, you will know that that region offers Aurora, because Aurora needs to write to a minimum of 3 zones. And it was only fairly recently, maybe about a year or less than a year ago, that you could get this, say, in Singapore, where data center space is extremely expensive because it's a little island. Now, on Azure, an availability zone is an AZ in Azure is basically a region, and in that you have there a fault domain as well as an update domain. So if you create 3 or more VMs across these zones in a region, your VMs are effectively distributed across 3 fault domains itself and 3 update domains. So Azure itself as a platform is a little smarter. It recognizes the distribution across update domains, and also will make sure that the VMs in your different zones are not updated at the same time. This, in theory, is good because when you're doing scheduled maintenance, means that on Azure you have higher availability than, say, on RDS. Now, RDS is still available during said maintenance, but has much higher elevated I/O workload. Now, when it comes to locations, Amazon RDS is in a huge chunk of locations, as is Google Cloud SQL. Now, Google Cloud SQL, you want to make sure you're getting the second generation instances. Also true for Azure Gen 5 locations, not Gen 4, except with Azure, in terms of cost, Gen 4 and Gen 5 cost the same, so definitely get Gen 5. They don't like to tell you where the data centers are located, which is kind of annoying. So things like Southeast Asia basically equate to Singapore, East Asia is Hong Kong, Australia Southeast is Melbourne, Victoria. Alibaba Cloud is extremely heavy in China. Many of these services also are say, in Mumbai. But Alibaba offers locations like Kuala Lumpur, Jakarta, which no one else tends to offer. Again, you need to go in for finer grain to look at how many zones you can get per region. But the trick with at least Amazon is to see if they offer Aurora, then you know they have a minimum of 3. And this keeps on expanding further and further. So when it comes to SLAs, everyone's fairly certain that you should have very little downtime per annum. Basically, if you have 4 nines uptimes, or 99.95% uptime, you really shouldn't be looking at downtime that's very long at all per year. And everyone tends to offer you some kind of service credit, with the exception of Alibaba Cloud. Of course, naturally, the scheduled maintenance does not include the increased I/O and latency. Now, when I say 99.95% in a calendar month, that means you should never have more than 22 minutes of downtime per month. Of course, again, not during the upgrade cycle or maintenance cycle, so to speak. The maintenance cycle means that you could suffer up to 140 minutes of I/O latency, but generally speaking, no one will go down longer than 22 minutes. Now, when you say, can I afford to be down 22 minutes a month? The answer is probably no, and you will then create, obviously, more replicas. This is how you scale out in the cloud and be highly available. The chance of everything going down at one go is quite minimal. In fact, you will always find plenty of news outlets covering when a cloud region goes down. But this should not stop you, because you should be able to run in multiple regions. And if you need help for that, naturally, there are tools like Chaos Monkey that help. So you can do chaos deploys, and you can just kill nodes at any given time. Now, when it comes to support, they all have fairly cheap ramp-ups. I mean, you can start typically for like even $20 and go up. But they all give you varying levels of support. So you may be able to only get from local business hours like Amazon within, say, 12 hours of response time. And of course, it goes up. Now, if you decide that you want management, management tends to cost a lot more money. Amazon, for example, will sell you managed services, but it starts at $15K per year. That's generally quite pricey. Again, people like Google and Microsoft, Alibaba, they all generally give you self-management. But there are people like Rackspace Managed Services that will tell you they fully support AWS, Alibaba Cloud, Google Cloud, and so forth. So you can totally go and use an outsourced service like Rackspace to do it. And they truly have fanatical support. Every time I've had to contact Rackspace, I get responses the quickest amongst a lot. It's clear that support is in their DNA. And I used to also talk about Rackspace's cloud, but Rackspace's cloud is based on older version of OpenStack and not really very popular. I think they're refocusing on managed services nowadays, largely because they're owned by a private equity firm. Also, don't forget that there are many, many companies that do remote DBA services, right? So Pythian, Percona, MariaDB, who were at the expo hall earlier, they will all help you manage this as well. So you don't. But the only disadvantage, I guess, is you don't get a single billing service. You get you get to pay Amazon and you get to pay a provider like MariaDB. Now, when it comes to MySQL versions, AWS tends to be really, really quick in terms of updating. They offer, 5.5, 5.6, 5.7, and 8.0. Now, 8.0, as I said, has been around for about a year now, and 8.0 is really very, very performant, very useful. And from a MariaDB standpoint, they support 10.0, 1, 2, and 3. So with 10.3, you're getting the ability to do SQL mode equals Oracle and migrate your Oracle applications, workloads, and PLSQL over to MariaDB. Now, Google offers 5.6 and 5.7, but they seem to be lagging behind MySQL releases. You're getting fairly old 5.7. It used to be updated every maybe 4 to 5 months once now. Now, lately, it's been a lot longer in terms of Delta. Microsoft has been doing a good job of 5.6 and 5.7, as well as MariaDB Server 10.2. These are all fairly recent. Again, not seeing 8.0 or 10.3. And Alibaba Cloud, a bit of an anomaly here because they have 5.6 and 5.7, of which they heavily add on patches. They call it the Ali SQL patches, and you're allowed to go take a look at this on GitHub as well. Some of this goes upstream to MySQL, some of this goes to MariaDB. Now, the MariaDB offering is quite interesting because they don't actually offer MariaDB Community. They offer MariaDB Enterprise. So you are effectively using an enterprise product with a max-scale router, and you're obviously paying for said service. You're paying sort of an added premium, but you're getting an enterprise product, not the community version. Now, everybody else is only shipping community editions, so that you're getting basically what you get on your laptop or your dev environment, and what you get in the cloud. Everyone now tends to give you API access as well as standard MySQL client access. It used to be such that, with Google, for example, they'd only allow you to do it within App Engine. Rackspace basically said you had to access it via a private host name within the Rackspace network. Now everyone allow you to access this via standard MySQL client from, say, your laptop to an IP address. It's not a big deal anymore. Of course, if you are an experienced DBA, you'll find that you cannot configure MySQL as much as you can with these host services. So this was taken from 5.6. It was taken from MySQL Performance blog. MySQL itself provided 523 options that you could modify, while RDS would only give you via the web user interface 283 options. So a little over half. And 58 of those were immutable, so about half of the options were changeable. Of course, you can't change things like your base directory, your data directory, and various other variables. Since this is a managed service, things have to be locked down a little. But then it's also important to remember things like audit logs, the memcached daemon, all the binary log settings, performance schema. All this sort of is not turned on. Semi-sync replication, and so on. Now you can turn on performance schema via command line. You can turn on via an option group, memcached, and audit logs. But generally speaking, you're getting a very cut down version of MySQL, really just meant to deploy fairly easily in the cloud. Now, costs. Cloud unit economics are quite interesting, and they keep on changing all the time. Snap, the company behind Snapchat, basically said that they were going to spend $2 billion on Google Cloud over 5 years. That's a pretty penny. I think maybe in the news recently, in the last week, was how everyone said that in Lyft's IPO prospectus, every ride that you take on Lyft means Amazon gets 14 cents per ride. And some people were going, wow, that's crazy. Like Amazon's making 14 cents per ride. Now, if you've never actually launched a data center, kept that running, you may realize that 14 cents per ride is probably not as expensive as you think. But naturally, that does not stop commentary from coming saying, wow, it's crazy that Amazon's making so much. And you can expect that the same thing is going to happen when Uber files its IPO prospectus. Now, naturally, again, you can consolidate workloads. So sometimes RDS gets, or any service gets a new high memory instance, and sometimes you can consolidate workloads because it may have 3.6 times the performance versus the previous one. And if you have several workloads, you can consolidate and make them one. Prices always vary between regions. We find that the US is the cheapest. EU is obviously pricier. Singapore tends to be matched, if not pricier, because again of location. South America tends to be the most expensive, alongside Australia. Again, it takes a lot of effort to get cables down there as well. Now, we've seen price drops every year, but the last major price drop we've seen across all the clouds were about 3 years ago. Now any price drop is fairly marginal in the operation in the $5 or $6 region, if at all you see it. A DBM4 large is about $1,500 per year, and that price has been around since 2017. Now, a DBM4 large in Singapore, as a comparison, would set you back about $2,200 as opposed to $1,500. So that there is a 48% more expensive premium just by hosting in Singapore versus hosting in say US East or US West. Now you may be wondering if why I've only put a DBM4 large here, and that's because it turns out that Amazon keeps on updating the hardware, as does every cloud provider. But Amazon's been the one has managed to go through 5 generations, whereas Google and Azure have only gone through 2. You're basically getting the same amount of vCPUs, and they're giving you ECUs, and an ECU is a relative measure of the integer processing power of an Amazon EC2 instance. You're getting more ECUs, same amount of RAM, a lot more bandwidth, but at a lot less price. Well, not a lot less. Basically, $1,500 versus $1,533. So upgrading instances can give you more performance for maybe a little bit less price, and these keep on changing every couple years once. So, we can go back from 2013, 14, 17, and now to 2019, and you'll actually see the prices do drop. And it turns out cloud computing gets cheaper as the years go by, and you tend to get better hardware. So you're getting more bang for buck, so to speak. When it comes to something like Google, don't forget that you've got to enable billing. They've also got several first generations, so I don't recommend first generation anymore. And in fact, if you're a new customer, you can't get access to the D8 or the D16. But the closest you're getting to something that you can put into production today is a DBN1 standard 8, which will set you back about $6,700 per year. Now, Google has other limitations that are interesting that do not apply to say other database vendors. For one, a max size of a MySQL DB instance on disk is 500 gigabytes per instance, but storage is also included in the price that I list here. Now, you'll find that with Azure, for example, which will be probably on the next slide, storage costs are not included. So you gotta start adding these costs to realize which cloud vendor is going to be cheaper for you. Also, Google has max concurrent connections, and if you do package billing, you can save up to 50% as well. So down to Azure, where you can get a good test machine with 4 vCores, 8 gigs of RAM for about $3,000, but you're paying storage cost of 0.115 cents per gigabyte. This used to be 0.12 cents per gigabyte, so the costs have actually dropped over a year. And actually, they were planning to charge you by I/O, but I suspect it was maybe harder than expected to do via I/O. So now you're just paying these costs as is, no I/O. Alibaba Cloud, again, a similar comparison, about $4,500 for a similar machine. And if you take a subscription, a year-long subscription, you pay only about $3,000, and you can also pay for it monthly. Now, monthly payments almost unheard of in the cloud world when you're booking in advance. And storage, again, can be about 19 cents per gigabyte per month. In the US versus China, prices of course do vary. And they also add on additional features, audits, backups, monitoring, and of course all of this tends to cost you more. When you're hosting your application, you definitely keep it close to where your database is. So if you're keeping your database in Microsoft Azure, you do not keep your application in, say, Amazon's cloud. Most have multi-AZ, and Amazon itself implements multi-AZ via DRBD, which is block level replication across the availability zone. DRBD was also out in the expo hall. Naturally, you have good availability because it can do automatic failovers, but it can, if you have a large database and a cold start, it can be slow, and you don't get an extra read replica. You're basically paying for a passive follower. And if you compare performance with multi-AZ and without, there is a significant performance degradation with multi-AZ, largely because of the underlying DRBD structure. External replication, after 5.6 onwards throughout all clouds, actually works fairly well. You just enable backup retention, which will give you binary log access and will allow you to replicate from, say, Amazon to your own laptop, for example, or even this will help you get replicated out to another platform. And you can also replicate into these relational database services. And with Amazon, it started with 5.5. With Azure, it starts with 5.6. It's again similar around Cloud SQL, and they all usually have some kind of stored procedure that allows you to replicate into a relational database service. Getting started, it's fairly easy. You do MySQL dump, and then you load it. If you're doing upgrades tend to work just via upgrading read replicas nowadays. When it comes to disaster recovery, you need to have a plan. Naturally, don't keep everything in one region, and naturally have good backups, right? So you can't use a tool like Percona Extra Backup or MyDumper or Maria Backup. You're going to have to rely on Cloud SQL's basically automatic backup, or Amazon's automatic backup with point-in-time recovery and full daily snapshots, which also has a backup window. And Amazon does this most likely via EBS snapshots, because you can also create snapshots and save it in S3. Now, multi-AZs, you can do backups taken from a standby, which is much better. Obviously, you don't actually take load on your leader or master. You want to increase backup retention from 1 day to 7. And naturally ARIA, if you happen to use ARIA with MariaDB, which is actually enabled, this may not necessarily work for automatic backups, and it's part of the caveats and documentation. Microsoft also does automatic backups with point-in-time recovery, and backup retention is 7 days up to 35 days. Now remember, you can have all these wonderful backups, but restores can take an extremely long time. I don't know how many of you use a Pocket-like service called Instapaper, and they had a failure not long ago, maybe about 6-7 months ago, and they were down for more than 48 hours, not because they didn't have access to backups, it's because the restores of all that data took like 48 hours before you could get your read it later stuff. So this is extremely important to remember that there can be time for backup. So if you want to avoid this whole restore from backup scenario, the best situation is to have more nodes. When it comes to monitoring, you have things like CloudWatch, Azure Portal. They're all very good for monitoring, and Google really has improved their read-write graphs with the acquisition of stack drivers. So you got very good stack driver monitoring. Percona offers monitoring and management as well, and you can check this out. They basically package up Prometheus and Grafana and allow you to do monitoring. It's quite handy. And of course, there's Datadog, Vivid Cortex, and a whole slew of other monitoring solutions available out there. So your options are actually quite limitless. Now, MySQL and MariaDB have many storage engines, and MariaDB especially has things like MyRocks and TokuDB, Spider, Connect. It turns out that all these cloud vendors will disable every storage engine that you think is cool. They'll only allow you to use InnoDB and MyISAM. I used to also say they'll allow you to use ExtraDB, but MariaDB has obviously ditched ExtraDB for InnoDB, so realistically now you really only have InnoDB and MyISAM. When it comes to HA, you really want to make sure you plan for node failures. Nodes can fail as often as you think. Node provisioning is not as quick as you think, so it's not a 2-second operation, but can be a minimum 5-minute operation. Always backup. You may have bad nodes, at which point you can just kill said bad node. It's not a big deal. Google, as I said, is the only one that does semi-synchronous replication, so you actually get a usable replica when you pay Google for their high availability instance. And this means that you should set up alerts for replication lag as well. And I think Google's semi-sync is actually pretty awesome. Many cloud providers do not provide you everything. Storage engines are the least of your worries in terms of what they disable. There are many other things that are disabled, including things like replication filters, semi-synchronous replication, data at rest encryption, Galera cluster, the ability to use things like handler socket, performance schema, installing plugins, the latest cool stuff for MySQL 8, which is the X protocol and MySQL SH, which allows you to query MySQL using JavaScript or Python instead of just regular SQL. None of this will work with the existing cloud vendors. So these are all things that many people talk about, many people think are cool, but if you're using MySQL or MariaDB in the cloud, all this stuff just doesn't work. And this is just the tip of the iceberg. There's plenty more that gets disabled. Now, if you ever think of using things like InnoDB Memcached or audits in MySQL or MariaDB, Amazon does provide via option groups the ability to have both of these. InnoDB Memcached works only with MySQL, and the MariaDB Server Audit plugin works with both MySQL and MariaDB. You definitely want to have provisioned IOPS if you care about your database and you're going to use this in production, because the IOPS that are given to you sometimes are so limited. Like you may only be guaranteed like 100 IO per second, which is nothing for a database. Whereas if you do provisioned IOPS on, say, Amazon and also Google and Azure, you can go up to like 3 terabytes of storage. You can guarantee 30,000 IO per second per database instance. Now, if you're going to run in production, you want to have provisioned IOPS. Just remember the MySQL page size is 16 kilobytes, and you can generally increase the page size of MySQL, but it may not be exposed to you for all of these cloud providers either. And provisioned IOPS is way better than rating stuff yourself, because you can take provisioned IOPS up and down dynamically. Of course, again, if you're trying to do log forensics like the slow log, general log, you have to tend to download and then parse or use APIs and pull down log files. You don't get access to the super user to skip like any replication error if it happens to occur, and it can occur if you're using async replication. You can't just turn off the sync binary log. You don't get access to the operating system underlying even though it's Linux. So you can't just go out there and look at SA or TCP dump. Automatic upgrades. Regressions can happen in point releases of MySQL, and this is true of the MySQL of yesteryear and the MySQL of today. Now, I've given you a bunch of 5.5 examples, but we've also seen MySQLs in the 8.0 range have like one fix, which is a regression fix in a point release. Now, again, cloud vendors usually don't upgrade instantly, but you got to also make sure that these bugs are reported and it does not actually affect you. Otherwise, you may actually realize that you're getting nasty regressions where if you sort of relied on a query cache and then suddenly it's gone, your query performance can go down tremendously. Now, if you're going to benchmark stuff, Sysbench is probably really good for you. Basically, you can do OLTP tests and so forth. Yahoo Cloud Serving Benchmark or Google's PerfKit Benchmarker, which allows you to actually compare performance around Google Compute Engine, AWS, as well as Azure. There tend to be no roadmaps, so you have to, again, look out for mailing lists, posts. Typically look for the cloud vendor large events, right? So Google has a large next event. Amazon has this large reInvent, and Microsoft only recently started offering Azure SQL, so start watching out for Microsoft's events too. Now this is an example of poor usability in the cloud. Now, I won't label which cloud vendor this is, but what this allows me to do is to create a test database with a root user and a password. Now, I can actually create an instance without a password, which will then prevent me from ever logging into my instance because I did not initialize it with a password. This particular interface allows me to launch an instance without a password. That is a usability bug, because the only way to then fix it is to actually go kill that instance and start another one. So your mileage may vary, and I guess the maturity of these clouds also play a huge role in terms of what rocks and what doesn't. Now, you can also run MySQL or MariaDB inside of something like EC2 or a compute instance. You can do multiple geographic regions via, say, semi-synchronous replication even. You can run a single Percona server instance, because you can't get Percona server in any of these cloud environments, for example. Or a MariaDB server instance because you want to try out the latest 10.4 release candidate. Some good advice here is to use additional EBS volume for an InnoDB table space. You can use RAID on your EBS volume. You want to mount partitions with no A time as well as no dir time. And it typically should yield about 10% better I/O performance. You can monitor with tools like Isinga, Nagios, Percona monitoring and management. You can do your own snapshot backups and save it to S3. Snapshot backups can be done via something like MyDumper, which will also allow for parallel dump and load. You want to save money, you can use spot instances. MHA can help you with automatic failover. And of course, you can set up your own synchronous replication via Galera cluster or Percona XDB cluster. Stuff that you cannot get in the cloud naturally. You can't actually just easily get MariaDB Galera cluster, Percona XDB cluster. Aurora. Aurora is what Amazon tells you is a good idea for you to use after you've outgrown MySQL. I've also seen customers outgrow Aurora and then want to move to compute instances. So this is a very interesting dichotomy, that you can also outgrow what they consider very large scalable database. Basically, each 10 gigabyte chunk of your database volume is replicated 6 ways across 3 availability zones. They do make use of a quorum write, so either you get 4 or 6 different writes to increase write performance. It has self-healing, instant recovery. It's got its own commercial parallel distributed asynchronous redo logs. The cache is always warm through database restarts because the cache is decoupled from the database process. You can have up to 15 read replicas per leader for scaling your reads horizontally. Any read replica can also be promoted to being a new leader instantly this time with Aurora. And of course, you can have continuous incremental off-volume snapshots to S3 with backups having no load on the database at all. There are 2 variants of Aurora. The 5.6.10 fork, which obviously disables the optimizer because it's got all this other cool stuff and uses Aurora application. And also the 5.7.12 Aurora, which was launched about a year ago. And this one comes with things like JSON support, spatial indexes, generated columns, virtual columns, but no one is supporting the 8.0 variant yet. This is honestly fairly cool. Aurora is also has a lab mode, which will allow you to get even more optimizer features. And in the MySQL space, Aurora is the first to offer parallel query. Only again for the 5.6 Aurora, they're working on the 5.7 variant. But basically, from this picture, each node in the storage layer has got plenty of processing power. So Aurora can now make use of all the processing power by taking all the analytical queries you may run. So things like with window functions you may want to run. And run them in parallel across hundreds or thousands of storage nodes, which with a lot of speed benefits, so with several orders of magnitude. And this model, of course, reduces network, CPU, as well as buffer pool contention. You can definitely do analytical as well as transactional queries simultaneously on the same table while giving you high throughput on all of those queries. Now, parallel query is something you've seen in other databases like Postgres. We don't see this in any open source variant of MySQL either. So parallel query is something new, it's Aurora new. And I guess this is kind of exciting because we may start seeing more interest from the MariaDB and MySQL space as well to get this inside a regular server. Now, kind of looking ahead, we expect that you'll see things like auto-tune crop up more, which allows you to tune database deployments because it reuses training data from previous tuning sessions. And auto-tune itself doesn't need to generate initial data set for training its machine learning models. So basically, your tuning time is drastically reduced. And auto-tune also generates a configuration that's almost as good as chosen by DBA. And they actually made a blog on the Amazon blog which tells you that their auto-tune configurations and say EC2 basically gave the 60% reduction in latency and a 20 to 35% better throughput compared to what a DBA would configure. So sort of a self-driving database. Now, I put a little Oracle banner here because it's an Oracle ad that you see very commonly in the Wall Street Journal. They love to tell you it's a self-driving autonomous database, but this is for Oracle, not Oracle MySQL. But in the open source world, we see auto-tune as potentially useful for this sort of thing. And then Peloton is the self-driving DBMS that's built on top of auto-tune, and it also kind of can predict future workload trends before they occur, and it makes use of the Postgres wire protocol with integrated artificial intelligence as well as machine learning. It's made by the same people who do auto-tune, and it's from CMU. I think I don't know where Peloton will go, but I think auto-tune is something you'll start seeing more MySQL use cases for. So if you use MySQL 8 today, you can actually it actually has default tuning options that make it more usable from an InnoDB standpoint. And I expect this will only get better over time. MariaDB is also working on tuning, and they made some announcements last week at OpenWorks, their conference, but they didn't quite. There's no code. It's still a lot of slide decks at the moment. So a quick amount of closing thoughts because we've got approximately maybe less than 3 minutes. Hardware obviously varies per region, so you can get older hardware in some of the Amazon regions, for example, and it's becoming quite apparent that the others are telling you, look, we got version X of a database and version X plus 1. Software manageability can also vary per region. Again, this depends largely on what kind of hardware is there and what kind of software they've deployed on top of it. This used to be more of a problem in the OpenStack world, a lot less of a problem in these current closed environments. Credit cards. Not using this well can make your credit card go to the roof. Famously, I don't know how many of you have used SmugMug before, but they recently acquired Flickr. But the guy behind SmugMug, Don McAllister, used to walk around with an Amex Black Card largely because he was an early adopter of the cloud, and they spent so much money on Amazon that it generated that for him. With regards to credit card, make sure you have a backup credit card as well. So Google, Amazon, and so forth, they all allow this. You want to make sure that you have a backup credit card because if your credit card fails to bill for some reason, like limit was hit, or you happen to close the account due to fraud, you could be fairly miserable fairly quickly in the cloud, because these are all run by machines. Oh, I couldn't charge this person. I'll send an email. Oh, I still couldn't charge you. Okay, maybe I should suspend your service. Not very pleasant. Definitely don't upgrade immediately to the latest new releases. We see lots of this, especially with Aurora. They go from 5.6 Aurora to 5.7 immediately, and then and shortly after they go, it doesn't work the same. Like, yeah, it's true, because 5.7 it's not MySQL 5.7, it's Aurora 5.7. It's kind of a shell of MySQL, right? So don't upgrade immediately. Wait for others to upgrade in test environments, and so forth. Always read the release notes. Some release notes are better than others, but always read them. If you're doing the whole EC2 route, look for other managed services, right? So MongoDB, for example, has Atlas for cloud management. We don't see much of this in the MySQL world yet. MariaDB has been talking about doing this since last year, so hopefully we'll see more of this soon. Definitely, if you're looking for sharding, check out Vitess, and if you're looking for proxies, things like Proxy SQL kind of rock. Well, with that, thank you very much for listening. Clearly, the SCaLE diehards are here till the end. Do you have any questions? Or the slides will be up online as well, as will the recording. So thank you. Sure. Let me fire up Keynote again. The last screen. This one? Or this one? Okay. All good? All right. So you are clearly a SCaLE diehard. You're also a SCaLE diehard. You're here till the very end. Yeah, yeah. I was contemplating leaving today as well, but I didn't really get to do it today. My flight is about tomorrow morning.